Okay, in the previous video, we proved this identity. In this video, we're going to prove these two identities. So I'm going to start with identity number 2. So identity number 2 says the following. It says that f convolved with g1 plus g2 is equal to f convolved with g1 plus f convolved with g2. And similar to the second proof we did of the in the last video, to prove this, we're going to prove that the Laplace transform of f convolved with g1 plus g2 is equal to the Laplace transform of f convolved with g1 plus f convolved with g2. Okay, and again, why does that help us? Well, using this fact up here, if we know the Laplace transform of these two functions are equal to each other, it means the two functions themselves are equal to each other. So I'm going to start by computing the Laplace transform of the left-hand side. So when I do that, using the fact about Laplace transforms and convolutions, the Laplace transform of g1 of f convolved with g1 plus g2 is equal to f times the Laplace transform of g1 plus g2. And again, I'm using f to be the Laplace transform of f. Well, what's happening in the brackets here? Well, the Laplace transform of g1 plus g2 is just the Laplace transform of g1 plus the Laplace transform of g2. Because remember, the Laplace has this linearity property. Okay, well, this is just f times g1 plus f times g2. And now, using the fact about convolution and Laplace transforms again, this is equal to the Laplace transform of f convolved with g1 plus the Laplace transform of f convolved with g2. And again, using the linearity property of the Laplace transform, this is equal to the Laplace transform of f convolved with g1 plus f convolved with g2. So in other words, the Laplace transform of f convolved with g1 plus g2 is equal to the Laplace transform of f convolved with g1 plus f convolved with g2. And so this tells us that f convolved with g1 plus g2 is equal to f convolved with g1 plus f convolved with g2. Okay, now the next thing we're going to prove is this associative property that says f convolved with g convolved with h is equal to f convolved with g convolved with h. So the way this works is on the left-hand side, you do this convolution, and then you do that convolution. On the right-hand side, you do this convolution, and then you do that convolution. Okay, and again, just like we proved the other facts, we're going to prove it using Laplace transforms. In particular, we're going to show that the Laplace transform of f convolved with g convolved with h is equal to the Laplace transform of f convolved with g convolved with h. Okay, and that's going to prove, again, using the top fact here, that's going to allow us to prove that the two functions are equal. Okay, so how are we going to do this? The Laplace transform of f convolved with g convolved with h, using the fact about Laplace transforms and convolutions, this is the Laplace transform of f times the Laplace transform of g convolved with h. Okay, now we're going to use the fact about Laplace transform and convolutions again. And this is the Laplace transform of f times the Laplace transform of g times the Laplace transform of h. Okay, and now I can put parentheses like this because remember, multiplication is associative. So I can put the parentheses like this. And so in parentheses, this is the Laplace transform of f convolved with g. And now we're multiplying it by the Laplace transform of h. and this then is equal, again, now we're going to use the relationship between Laplace transforms and convolution again, and so this is the Laplace transform of f convolved with g convolved with h. Okay, so in other words, since the Laplace transform of these two functions are equal, it allows us to conclude that f convolved with g convolved with h is equal to f convolved with g convolved with h. And one thing that this lets us do is it lets us write all of this convolution just as f convolved with g convolved with h without having to put parentheses. Because if we didn't know this associative property was true, this would not necessarily be true. Okay, or it would not be a well-defined thing. So anyways, I think this is really interesting, proving these identities about convolution, not by just looking at the definition of convolution, but by using this other fact about how convolution and the Laplace transform interact.